Hello, everybody. My name is Nick Miller. Thank you for joining us today. We're going to discuss multi-agent systems, a software development revolution. Our agenda for today, we'll start with the intro of me, but we'll keep that short because the interesting stuff is the AI agents. Next, we'll go on to defining what is an AI agent. So we have a little bit of a foundation for our discussion, and we'll talk about why agents are going to be the next step in software development. We'll talk about how agents change development fundamentally. We'll talk about what that means for opportunities for businesses. And then I'll build an AI agent to to show you how that works, some of the pieces that go into it and how to set up those resources. And then we'll talk about some considerations at scale for agent systems. And then we'll have a little bit of time at the end for Q&A. First of all, I just want to introduce you to myself. I'm Nick Miller. I'm based out of Austin, Texas. A long time ago, well, maybe not that long, I went to University of Texas at Austin, got a management information systems degree, and from college I left and joined the Navy. I was a logistics officer in the Navy for 10 years active duty. I got out and I went to the UT MBA program because all I spoke was military and I wanted to speak civilian and I didn't even know what an ERP or any of that sort of stuff was. So the MBA was a good transition for me. And during that program, a little bit after that, I started working and I got married to my wife, Heather. I realized during the MBA program that I loved my statistics class, and we got to hear from the manager of risk and fraud at Apple. And I think, wow, this is what I want to do. I trained my first classification model in 2012. And I thought, man, I'm a god. I can predict the future. And I thought this was amazing. And so I found out that you couldn't really get a job as a data scientist in 2013 without a master's degree at minimum in like math or statistics or econ. So I went back to A&M and got my master's degree in statistics. These days, you can see there's a picture of my family and I've got two kids, Sadie and Bam, and then we have two dogs. And then I found the true love of my life. Don't tell my wife, just kidding. Golf. It's a fun challenge and it's always something that I think is a good life lesson and helps you grow as a person and in the sport. But enough about me. Let's talk about what is an agent. It's important to think of agents as a system. It's not just a single thing. It's a component, a system of many components. And at the core of it is a large language model. And you've heard of, GPT-4o or any of these sort of LLMs, Llama. Um, that LLM combined with things like performing actions. So you give it a set of actions and directions of what it's supposed to do, sort of like an identity of its tasks, its mission in life, sort of thing. Then you give it access to tools. And these can be called different things depending on the software toolkit you're using, but some people call them plugins, some call them skills. And so you give it access to tools, those may be APIs or functions or other things like that. And then you give it knowledge. And the knowledge can be vector database knowledge. It could be other types of knowledge, just access to information that you want it to know. And those three components, along with an LLM, is an agent. And the way that is manifested depends on the software toolkit. But if we talk about Agent Foundry or things like that, it's a software SDK where you define the different components, and then there's a class that you define an agent, and now you have an agent. Um, so the next thing is, well, when do you use agents? Like, why would you use an agent? And you just use it because agents are cool and fun? Yeah, sure, right? Maybe that's a fun little hobby project to start, but LLMs and whatnot are not the cheapest software to run, and so you want to use it for the right purpose. You don't want to use it just for anything. And in general, some criteria for the understanding when you would apply an agent would be these three things here. One, is it an open-ended problem? If you have a business process that is deterministically defined, there's nothing really that changes in it. There's nothing open-ended about it. It's business logic and all works. That's not a great use case. But if you have a business process that maybe has 6 steps, but you may not need all of them, and you don't really know when you might need them until you're in the process itself. And that's really where humans are doing well. But traditional software does not do well. Those are really where those agents shine. It's an open-ended problem. If it's multi-step processes, um, Now, multi-step process agents, you don't have to have a multi-step process just to use an AI agent, but you probably want to have a multi-step process if you're using a multi-agent system. So you could have a process where you are just extracting information and interpreting it, and that's it. And that's a great use for an AI, an LLM, but maybe not an agent. But if you have a multi-step process where maybe one agent needs to do something, another one needs to check it or validate it or do some sort of other specialized function, that's where AI multi-step, multi-agent solutions come into play. And then also, if you need something to improve over time, if things are going to change, if things are somewhat dynamic, then that's another case for agents, because the agents allow you to accomplish business tasks without rigidly programming a set of rules. And in fact, you can envision a scenario where you give your agent instructions. And if you think back to what makes an agent, a list of actions to perform or some actions to perform, maybe the actions and what it needs to do is defined in a business document, and instead of reprogramming everything, you just give it a new business document and it now has a new identity. So that's an example of where you're improving or you're modifying or incrementally changing things over time. That really takes advantage of the dynamic nature of agents in general, and then multi-agents make that even one step more robust. All right. Amy, do we have any questions so far?
Not that I am seeing yet.
Okay, great. I just wanted to check. So
no problem.
I'm making my presentation screen. So to the folks on the call, if you have a question, please just type your question in the chat and we'll answer them as they come up. You could hold them to the end, but if you're like me, you'll probably forget your question. So go ahead and ask it. If something comes up, go ahead and put your question there in the chat. All right, continuing on. So now we've talked about agents and what are some good use cases. Let's talk about why agents are going to be the next big thing in software development. And really what we're going to see is we're going to see a shift from SaaS to AI-centric orchestration. And Satya Nadella, you may know him, CEO of Microsoft, he says the era of SaaS as we know it is coming to an end. Now that doesn't mean that SaaS itself is going to disappear. It just means that SaaS as the tool, as the platform with which you interact, will not be we're not going to log into websites as much, a SaaS website, and do everything as they've defined it exactly in the business process and flow as they've defined it. What we're going to see is that isolated SaaS tools are going to be subsumed by an overarching AI orchestration layer. And what that means is that AI orchestration, if you remember what we talked about, what's an agent? Well, it has a list of actions, but it also has a set of skills or tools. Well, you could think of it really what SaaS is going to come to is SaaS will have a bunch of APIs, individual tools that agents will leverage when they need to leverage them. And so that's really where we're going to see a big change. We're going to see that those AI agents are acting as that central brain, orchestrating some enterprise logic seamlessly. So as business processes change, you don't have to completely reprogram that SaaS layer, the business layer. It's taken care of by that agent orchestration. So that's where it allows you to have a dynamic business process. So the problem that these multi-agent solutions solve is they solve process and integration complexity. Traditional SaaS tools have complex and fragile integrations. If you've ever integrated programs with SaaS, you'll know that if something changes in the business process, you either have to adjust your business process to the SaaS tool, or you have to like customize or create this custom code, and it's complex and it's fragile. So that's where we have that orchestration layer coming in. And so in order to make this a little bit more real, we're going to walk through very briefly just a real example of a customer support and ticket resolution. The traditional solution might look something like this. You have a customer support person who's at a computer terminal. They maybe have access to Microsoft Dynamics CRM, where they have FAQ information or they have relevant articles. So when the person calls in, when a customer calls in, they can look up an issue and get information, because customer support technicians, they don't always know the answer themselves because there's so many different things that could be asked. So they have to go reference these manuals and look in there. And what that means is you have a bunch of people who are really, like, they're good at finding stuff, but they're not really a master or really understand all that information in a deep way, unless maybe they're like a very senior technician, have been there for a long time, they really understand the tooling. But if you can imagine systems or processes that change frequently, it's hard to keep up with it. But that's how it happens. They have the system, they log in, they research things, they find answers, they give they answer the ticket. The customer may not be happy with the ticket, and that may go up to the supervisor, or there's a certain threshold, so maybe it needs to get pushed up to a shift manager or something like that. But it's a highly repetitive process. There's delays in it. It's error prone, and that's kind of what you might see. You may have been involved in this yourself, or you've been a customer of one of these types of solutions, but it's kind of slow and it's not ideal. So what a multi-agent solution looks like, and sorry for the icons, every agent has to be like a computer or like a robot, a humanoid robot. So, but these little icons here, these are what you would, maybe this is the way I envisioned an AI agent, or at least a good way to visually represent an AI agent. But that same thing in a multi-agent solution is you may have a customer service AI agent, and this customer service agent is the only thing that the customer is interacting with. So you could think the customer connects with the customer service agent, they tell them about their issue. The customer service agent may have skills like opening their account information or looking at service tickets or anything like that. And the customer service agent asks questions so they understand the issue. And then they may, when they have a resolution, they'll put in the multi-agent collaboration area, they'll put here's the issues, here's my resolution to that. And you may have a AI agent that's purely focused on compliance. Maybe there are business processes or regulations that you need to comply with when you're interacting with your customers, or maybe it's just internal business compliance. So the customer service AI agent is getting creative and coming up with a solution. And this pattern is commonly called like a maker-checker pattern, where you have the checker, the compliance agent, that is specialized in just, all they have to do is just ensure that anything they do is in compliance with the current business processes or rules. And that compliance agent has knowledge, it has access to whatever the business documents are. We don't have to program in that compliance line by line. We just give it the documents that it needs to comply with. And then if the compliance agent approves the resolution, great. If it doesn't, it'll give feedback to the customer service agent. This solution does not comply with this rule, da, da, da. The customer service agent can then try to come up with a little bit better resolution, and then go through that compliance check. And we're actually going to look at a multi-agent in some code, a little bit different scenario, but a sort of a maker-checker pattern. We'll see what that looks like. And then there may be, if the customer is not satisfied with the resolution, maybe they try a different option. And so after 2 or 3, rounds of this, or if the customer just says, I am not satisfied, I want to talk to your manager, I want to escalate this, maybe that then goes to an escalation agent. That agent can be responsible for interfacing with the human in the loop, so they can manage escalations. They can maybe put priority on escalations so that a human managing this process can see this, or maybe there isn't a human in the loop. And those decisions are business decisions based off of value and risk. And so you can think that there may be a human in the loop and there may not be. But regardless, let's say that this is an externally facing solution, and the resolution was to refund the customer for their $10 purchase. And so then the customer service agent gives its resolution that's been approved by the compliance agent, and it gives that to the finance agent. And the finance agent has some tools to process refunds. And so it gets the information from the customer, it gets the notes about what the refund is and the reason why, and maybe there's special coding so we can have business processes to help us understand when we're refunding, when we're not. Maybe it's a failure mode or things like that about the tooling, about the product. And maybe there's the finance agent has some information about, for certain products, there's a minimum threshold. And so over $15 has to be approved, and the finance agent can handle the refunding and also the management of those exceptions and when it needs to have a human approve it. But since this one's $10, it says I'm okay with this, and it just goes and processes that refund. That's what an example of a multi-agent solution would look like, and it doesn't involve all these different queues of people. It has queues of agents, but the thing about agents is they have very scalable capacity. So this process happens very quickly and it's pretty much in real time while you're chatting. So you can get your issue resolved very quickly instead of waiting days or hours for a ticketing system to go through escalation patterns, be in a queue, finally get worked, et cetera, et cetera. So that's what the new world of AI agents may look like. So the next thing we talk about is how AI agents change software development. I mean, I think you can get an idea for how solutions change just based off of what we said. But what about what we talked about, how AI agents will subsume SaaS tooling? Well, what that means is if you now you have these siloed SaaS logic layers, we go to a unified AI orchestration layer. So what happens is these SaaS tools become modular components used by AI agents, and those modular components were those tools that we talked about, right? So an agent has an LLM, it has actions it can take, it has tools, and it has a knowledge. And then what we'll see here is that agents are going to be replacing workflow logic embedded in the SaaS product. So you actually have to you have to go in there and program the business logic. It's very brittle, very structured. You know, if the SaaS product is good, I remember the big thing in SaaS was it's not customized, but it's configurable. Like, ooh, wow, you can flip all these like little levers and you kind of get what you want, right? Highly configurable. Well, that's good. Still brittle, still doesn't do everything we need it to do. And what we see is that without rigid programming and logic, we can have these dynamic workflows leveraging all these different SaaS tools to do the things we want. Because you don't necessarily want to reprogram an accounting tool. Like you want to make entries, like QuickBooks or something. If you're a small business, you still want to be able to deposit checks and bill customers. You don't want to, you don't need to rebuild that from scratch. But the way you interact with it maybe is different. Like the process for how things get approved may be different. Maybe you don't want to, if you're a small business, maybe you don't want to handle all the complaints, and maybe you have a process that handles refunds. And that all needs those SaaS tooling in the background to call those APIs, but you just don't want to be stuck in a certain process. So that's what it looks like. And when you have when you have an architecture like that, what it means is that you get dynamic process solving, process optimization, and innovation for new workflows. It's really a force multiplier for every domain. You really get that automation. So simple processes, and it can go from simple all the way to complex across multiple SaaS tools and legacy products. And then what you also see is AI agents are dynamically solving problems and optimizing processes. The next thing we see is that there's a competitive advantage that comes with using AI agents. And you may have heard a little bit about this if you were in Brian's talk about creating a business case. That if you're leveraging these, you're creating a competitive edge for your company to have higher agility, speed, and efficiency in your processes. If you have better customer care, maybe your customers are happy. Maybe you get better retention of customers because of those processes. Or you have tooling and processes where the product itself is hyper customized for customers. So they get a very customized experience when they're using your tool or your service. And those two things right there are really where we're going to see companies define their competitive competitive advantage by using AI agents. So next thing, what we're going to do is we're going to build an agent. And I'm going to walk you through that process. And what I want to show you is what does this look like on the background. So here in Azure, the first thing what we create is a Azure AI Hub. And within Azure AI Hub, I'll open it up here. This is what it looks like. So in Azure AI Hub, you can generate projects. And projects are a great way to sort of demarcate tooling and resources. So you can all the tooling and resources associated with a certain project. Maybe it's a test project. You can blow it away and then it doesn't affect all your other tooling. You can have resources that get created just for that project, or you can have models and deployments of LLM models across projects. But what we'll look at is we have this a hub, and we have a project. And so we'll go into this project here. This is the multi-agent demo, and we can open the project. And you can see a lot of information about the project. Its name, the resource, subscription ID, all that sort of stuff. And over here is what you could see. How you see how up in the hub it has models and endpoints, and then in the project's models and endpoints. Well, that's because we defined earlier just that models and endpoints can be specific to a project, or they can be part of a larger hub, which is available to multiple projects. And the first thing that you're going to do is you're going to want to deploy a model. And I already have one deployed here, but you could deploy a base model or a fine-tuned model. And you really can look at a lot of different models here. Does it have open source models? Yes, it does. Makes those available to you. All right, do you want a GPT model? So it has a model catalog of 128 models, and you can filter that based off of things. Is it from Azure, is Microsoft, is it Mistral? So you can find the things you're looking for, or maybe can you do a managed compute or a serverless, or what do you want it to do? Do you want to do embeddings or translation or there's all these different kind of use cases. So you can kind of filter the AI model you want for a big task. So whatever, you find what you want. Maybe we want a GPT-4.1 mini. And you just confirm, and then you're going to name it, and then it'll tell you this information about the deployment details. You can see like when does it upgrade, what's its token rate per minute, those sorts of things, and then you just click deploy. All right. And at this point, now you have a deployed model. Pretty easy, right? So at this point, and we're talking about an AI agent, we have an LLM. We just deployed a model, an LLM to an endpoint. So now we have the LLM. Here's its URI. So here's how we can access it. That's the API. Here's the OpenAI SDK endpoint. So it gives you all the information you need about your model. It tells you how to authenticate to it. Here's the dependencies we need to use, etc. So that's our model. And so we have right here, this is the model we're going to use for this project. But that's what you do. You start with that. And then after we have our model, we can go, the next thing we're doing this first project is we're also going to look at AI search. And AI search is a search service. So basically what it does is it allows us to take external data, maybe it's PDFs or it's document data or JSON files or any other sort of company specific data that we want to use and make available to our model. In this case, we have an index with travel documents. Now, this is a pretty simple POC because we have 50 minutes for the whole thing. And so, we're not going to build a monolithic or a giant project here, but this AI search document index has 5 documents. And you can look at the index and just so you know, there's some stuff about destinations, right? It's like our mythical application is a travel company, right? So we typed in destination and it found 2 documents that matched. There's one that talks about popular destinations, and then there's another one that says Contoso offers luxury packages to vacations. Okay, so I just wanted you to see that those documents are in there. But what we're going to do is we're actually going to delete this index because we're going to create it in code, but we're going to delete that index. But the idea here is that we have AI search as a resource and that we're going to put some documents into the index. And then there's a process called vectorization. And what that means is it takes the AI agent will take your query and it will convert it into a vector string. And the vector, it's a vector array, and you can define the length of them. It could be 1,048 or it could be 3,000, 6, whatever. There's all these different sizes. So the bigger the vectors are, the more memory you use, and so it can change your pricing or cost structure. But what it does is it uses Euclidean distance. And so what is that? It's just to say that it uses a mathematical formula to compare the vectorized version of your question to vectors in this in this index, and it finds the top, I don't know, like say 10 or so that are similar to what you're looking for, and then it returns those results, and it gives those results in the plain text to the AI agent. And so now the AI agent has more information. So when we talked about what is an AI agent, we talked about it's got like an identity of actions, its mission, and then it has tools. We talked about APIs and things like that for SaaS, and then it has knowledge. This right here is one way that we can imbue it with knowledge. All right. And so now for us, the next step is for us to look at the code. And the first thing we're going to look at, and this is a little bit of big text, but I'm hoping that it is legible for everyone, even if your monitor is not huge. So the first thing we do is we're looking at some Python libraries. Right here, these top libraries right here relate to Azure Search. So we just looked at Azure Search in the index. So we have an index client, that sort of stuff. Then we have OpenAI, and we have semantic kernel. And semantic kernel you could think of as tooling that helps turn an LLM into an AI agent, right? Because we said that an AI agent has all these different, has the skills and the knowledge and all this sort of stuff. And you'll see that the kernel, the chat completion agent, is the wrapper that we put around the LLM and those tools and the knowledge. So you'll see that here. So you'll run this. And then, actually, let me clear this real quick so we can just start it over. All right. So we're going to create a kernel, and we're going to call this an agent, and then we're going to add a service, Azure Chat Completion. And this right here is how we're adding the completion. And actually, our deployment name is not, I wonder if this works. I think it's called O4 Mini, but it worked before. That's weird. Okay. So we're adding our LLM to the chat completion service. And so our kernel has access to an LLM. That was one of the things we needed. All right. And then we're going to give it a plugin. And this is the custom function, but we're going to give it a plugin to get context. So remember how we talked about getting knowledge? So we're going to get the query, and then we're going to find documents in our index that are similar to that, and then we're going to place the documents, the information from the documents back into the LLM. That's what we will call here an augmented prompt. So it's going to take your original question, and then it's going to get the context with your question and give it all to the LLM to answer. So that's what this step is. So building that. There's also a Weber plugin. So we talked about tooling your skills, right? So giving the AI agent tools. This is another example, a weather info plugin. Now this is just kind of make-believe because these are obviously hard-coded. But again, this could be an API call to a weather service or whatnot. And we'll have a function that will get the temperature based off of the destination. So when you ask for a specific destination, and even if you set it, even if you said the destination maybe like not in the right way, it'll figure that out for you. But this just returns the temperature. So at this point, we have two things. We have a single skill. We have the LLM agent, and we have a skill. And then now we want to talk about our knowledge or our memory. So right here's that vector database initialization. Actually, I need to run this code. There we go. So right here, we're going to create, if they don't exist, this index. And we deleted the index, but it's going to create that index called travel documents, and it's going to place these documents into the index. And remember how we searched about destinations, and this, I think this one came up second, and then this other one came up first. Well, these are the documents we're going to place in the index. So let's click this button here. And so we are creating the index and adding those documents to the index. Now, learning AI search in itself can get complex. There's a lot to learn there, but this is at a high level, creating those indexes and pushing it in there. And now we see, now we have this index is being recreated, travel documents, and we could search. Let's see what else is in there. Contoso. Oh, let's just search for hotels. What does it say about hotels? Provides exclusive access to boutique hotels. Wonderful. Okay. So the next thing we want to do is this last one here is get the just a helper function. So you query the index and return the top 2 related documents. Now it doesn't need to be 2, it could be multiple documents. It could be 5, 6, 10, 20, just depending. And then there's another thing that we talked about, and if you remember the presentation where you have the customer service agent and it has sort of this round robin control of how they collaborate, you can set that up and you can set it to auto or you can set it to fix. Maybe you're trying to test a specific agent interaction. So, you know, auto would make it impossible to test. So you can, instead of using auto, you can change it to other things like require a specific choice or none invoke. So, but right now we're going to let it make its own choice. So it's going to be auto there. All right, we are going to give it an agent, name, travel agent. And then the other thing, the last thing that we need, we talked about what makes an AA agent. You need that LLM, you need the tools, you need the memory. And the last thing is its mission. Hey, you are a agent that answers travel queries, providing the tools and context. If context is provided, do not, if context is provided, do not say I have no context for that. And then we're going to take that kernel, which has the LLM, and the skills and the instructions and the names. And right here, this chat completion agent right there, that's where we get our AI agent. At this point, now we have an AI agent in this object called agent. And we're going to use our function to get the augmented prompt. So we have this prompt, get our augmented prompt. And then we're going to run this. And basically, it's going to go through here automatically. And you can, a lot of this code is just HTML, so it looks pretty as it's printing out. You would actually not do this. You would embed it in a chat tool or some sort of like either chatbot query or Teams or something like that. But as you can see, it really is most of that formatting in there. But you can see it's blank here. But we'll go ahead and run this. And it's going to run through those 4 or 5 questions. I think it was 5 questions. So the first question was, can you explain Contoso's travel insurance coverage? Yes. 3 couriers. So it's, yep. So what does this context looks like? So this is our documents that we uploaded. So they got the context first and gave it to him. And it didn't just repeat, it didn't just find the context and like verbatim repeat it. It's like what you would do. You would get the context and you would explain it in terms relative to the question. And that's, you know, obviously that's what the beauty of LLMs. And so there's the context there. It says, which team will win the NCAA championship? Well, we already know what happened there, but when this was first created, we didn't know. But it's a travel agent. We've told it, don't make stuff up. Only answer for what you have context. And so the context we have is all the information we put into the AI search index. And thankfully, the travel agent AI agent says, I'm sorry, I don't have enough information to predict. If you let me know what year division you're asking about, I can share expert consensus. Oh, there you go. What's the average temperature of the Maldives? It gives you some information about temperature because it has a skill to get agents. So you ask the context, the Maldives, hey, we go to the Maldives. And then the query is this. So I know that we go to the Maldives. I'm the AI agent, right? So I know that we go to the Maldives, but I don't see the temperature. Oh, but I do have a skill that allows me to get the temperature for the places that we have destination packages to. So I'm going to make a function call. I'm going to get the destination temperature to the Maldives. And then I get a response. So at that, the AI agent decided when it's going to use the tool, and it decided rightfully that it's going to check the temperature. So got that one correct. So then they reply, A little embellishing, but that's okay. Maldives enjoys a warm tropical climate year-round. The average temperature hovers around 82 degrees with minimal seasonal variation, making it a balmy, reliable destination. Wonderful. What is a good cold destination? What's its average temperature? For here again, you got the context of where do we travel? And it knows, just because it's an LM, that the Swiss Alps are pretty cold. And Africa, not super cold, and the Maldives, kind of tropical. So yeah, let's get the temperature in the Swiss Alps because we know that's cold. So again, it uses its embedded knowledge, it uses your index knowledge, and it uses its tools to answer the question. So at this point, we have an LLM agent that is, I mean, obviously a very basic one, but we have a fully functioning LLM agent that answers questions. Now, of course, this is all, pedagogical. It's just for demonstration purposes, but you would actually want to use a real API for getting the weather. You would probably have for travel agencies like destinations, you may have lots of documents in there about the different locations and services provided, et cetera. But really nothing significantly is changing in this tooling. You're just changing the number of documents in your index or the number or like the specific API you're using. But in general, it's not really very different. The second thing we're going to look at is a multi-agent. So we talked about that customer service tool, and we discussed that we talked about a maker checker pattern, and that customer service agent could not actually was not allowed to propose a solution to the customer without running it through compliance first. And this is the same thing, but again, it's a fictional travel agency agent. And so you have a front desk person. When you're at a hotel, you go to the front desk and, hey, I want to go do something. And they may answer, but they have a lot of jobs as a front desk person, right? They're not really specialized in recommending places. But you do have a concierge person who is kind of overseeing, checking the work of the front desk person and giving them instructions. So that's what we're going to do here. So again, nothing that different here, except you have instead of you're going to define agents, right? You have your chat completion agent. But the other thing now that we don't have a single agent, we have two agents. We're going to have an agent group chat. And we also have this thing called chat completion. So that's how we know. How do we know when we're done talking? Like we don't want to talk in circles forever. So how do we know when we're done? That's what that's used for. So first thing is we're going to create that kernel. We're going to give it an agent, and then we're going to assign an LLM to it. Okay, so now our agent, we have an LLM service. Well, that's one of the four things we need. Right here, we're going to do the other things. We're going to give it a mission. We have a concierge, and we have a front desk. And so they're both given their missions. And your hotel concierge, you want to provide local, authentic experiences. And your goal is to determine if the front desk travel agent has recommended the best non-touristy experience for travelers. And then you have a front desk person. You provide the best activities and locations. Now, you don't necessarily know, I guess the front desk agent doesn't really know. You're known for brevity because, you're busy. You have other things to do. All right, so then we define our chat completion agent. And here's the front desk. So we've defined those two agents. They have a mission. They both have an LLM assigned to them. And the other thing they'll need is some sort of memory. Well, that memory in this case is programmed into the LLM, but you could also see that we could assign tools for APIs like to check ticket prices or to check weather or things like that. Or we could put specific travel information into documents into an AI search index. Now, we're not doing that in this example. We're only focusing on the multi-agent interaction, but you could see from what we previously did in Notebook 5 that you could very easily do this. And then the last thing is, how do we make sure that our agents just don't talk in circles? And that's this kernel function from prompt. And the function name is termination. So this is how we determine if we are exiting the conversation. And then the next part is will function to determine whose turn it is next. And so you get to choose from these people, these agents, and these are code. So you could have multiple in here. You could have multiple reviewers or multiple front desk folks, et cetera. And it kind of just defines how the chat works. Like we're taking turns. After this person replies, it is the reviewer's name. Now, this is when we talked about SAS and we talked about business logic and brittle. Think about this. This is how the business logic is defined. It's pretty flexible, easy to redefine and modify. So that's it right there. And then the last thing we do is we put that group chat together. We put the agents in there. We give it that termination strategy. We give it the kernel that we created earlier, those termination and selection strategies. And then we give it an input. I would like to go to Paris. And then we let the agents just chat. And you get different outputs each time you run this. So user, I'd like to go to Paris. The front desk person is busy, I guess, but there they go. So, hey, visit the Louvre. Book a skip the line ticket. You want to see the Mona Lisa, it gives you the rooms. It's actually pretty good advice. Allow 3 to 4 hours. Then you can unwind in the, well, I don't speak French, Tuileries Garden. And then, but the concierge, no, we need to get more artsy. Not approved. It's very cool, but it's too much towards been there, done that. How about something like small scale venues like galleries or community markets? Emphasize timing and context. And so the front desk person does listen to the concierge, says, you know what, explore the Canal Saint Martin like a local. Begin with a pistachio filled croissant at Dupain, something or other. That sounds pretty good to me, actually. I'd love a pistachio filled croissant. And then browse some indie boutiques. That doesn't sound as fun for me. Grab cheese and cured meats. Yes, I'm in. Picnic on the canal's stone footbridges. That would be great. And then captain afternoon with an apéro at the Hotel du Nord. Sounds great. The concierge looks at that plan and they say, wow, that's great. That actually is what we're looking for. This is something a little bit more unique, and it's not the been there, done that. Now we can run this again and we'll get a different output because, again, we didn't program it to say, oh, always go to this thing. The agents are using their tools and their knowledge to answer the question. Now, of course, you might, like in a real application, you wouldn't just say, I want to go to Paris. I mean, okay, well, what are your interests? Well, I have a 60-year-old person who uses a cane, and I've got, I have a 10-year-old who with me that likes this, that, and the other. Well, in that case, that would alter the recommendations you get, right? So I think obviously this is still, like we said, pedagogical, but it gives you an idea of how you could, what it takes, not much, but what it takes to create a multi-agent interaction. They wanted to explore. I've never heard of this, so this is probably approved, but it's a artisanal cheese place. So it didn't give us the same recommendation. It recommended something else. But anyways, you could make this a back and forth. And so it's approved. So then the front desk recommends it. And then the user could be like, well, I'm not really big into artisanal cheese. So then it would go back and it'd go through this process again. So you could see how this could become more customized. All right. Well, that is the end of the building. So hopefully that gave you some idea that although there are a lot of Python libraries, and it's not nothing to learn this, but you see that there isn't a ton of code to create a very basic app that makes this work. Now you want to embed it in a better chat interface. But hopefully that gives you a little bit of confidence that this is something that you could possibly do. All right, we'll continue on. We'll talk about considerations at scale. So now that we've shown how to create an agent, what do you have to worry about? Okay, let's do multi-agent systems everywhere, across every business process, and let's do it, and it'll work out great. No worries. And that may be true, but there's some things that you want to consider. So there's performance bottlenecks. If you remember, we did that example, it took, I think, 6 or 7 seconds to get an answer. In some cases, 6 or 7 seconds may not be acceptable. That won't work for the business process. In that case, what you have to do is you have to find an LLM that performs well enough, but is faster. So in that case, maybe you want to use, like in some cases, a mini or a newer agent, or maybe the latency is not as much of the issue, but it's the cost. And so maybe you use, you then you have a bunch of examples and you run it through your performance checking to make sure it's answering correctly, but it's more about you're trying the cheapest LLMs that you can look at, right? So there's considerations, right? You could just pick the most expensive one, but maybe that's really not the best thing, right? You don't always want to pick the most expensive tooling possible. It may be required in a certain case, but maybe not. And then the other thing is your APIs. You want to make sure that as these systems scale, that the tooling you give them is scalable enough, because it's going to be calling those APIs multiple times. If it's super popular product, then you're going to need to worry about concurrency and other things like that. And after you move past performance bottlenecks, you have ethical concerns. In general, there are some concerns that we look at, like avoiding bias or fair decision making. If you have a multi-agent system for interviewing candidates, you definitely want to make sure that you are programmatically avoiding bias in your interviewing process. Maybe your agent just doesn't like people named Nick, and rightfully so. But just kidding. But you just want to make sure that you don't get yourself into trouble. So it depends on the system, the situation. In general, I wouldn't start my AI journey as a company with really risky solutions from an ethics perspective or business risk perspective. You typically want to start a little bit lower risk, so you can get comfortable with that and learn how to manage that risk. The last thing is agent collaboration. Right there we had where the agent, the front desk and the concierge were going back and forth. That may be great, no big deal. Or maybe you have like 6 or 7 agents working together and you want to keep track of that process or optimize that process so that it's efficient and it's not getting stuck or that it's not doing weird things in the process. You just want to make sure that that's in there. So that's something that, although it didn't take a lot to program that, there can be systems or whatnot where you're wanting certain outcomes in certain situations. You have to validate that and make sure your agent collaboration is working. And the last thing is designing for scalability. So not only do you have those challenges, you also have to design it properly. So you could use Azure AI Agent Service. It's modular design. You got visibility into what's happening. You want to see you actually want to have visibility, although the user may not see the front desk and the concierge communicating. Maybe you do want to expose that, but at least you need to have that on the back end so that you can reference that later to understand what happened. Maybe you got a complaint about a user interaction. Well, what were the agents talking about? How did they get to this answer? And they may help you design or tweak your interaction instructions. And then the other thing, design for scalability. Responsible AI. We talked a little bit about this from the ethics perspective, but transparency. They should know they're talking to an AI agent. Don't try to fool them and make them think it's a human so you can save cost. Just be upfront with it. The other thing is you want to make sure it's reliable. It gives the right answers, that ultimately somebody's accountable for the agent. You can't be like, your agent system did something terrible and you're like, well, it was the agents, not us. Well, you're still accountable for it. You created the agents. And so you have to know that that's part of the process. And then these other things, fairness and performance. Other things to consider would be security, encryption, encrypting of data. I think those things come baked in with some of the Azure tooling. We can talk about isolation. How do you make sure that certain users only have access to their data and not, prompt injection and things like that? Those are concerns to look at. And then authentication. One of the things that you do to kind of manage that is for the skills and the tooling, you want to make sure that users are authenticating to this agent system so that when the tools are being used, they're only accessing records or data or things like that for which they have access. That's pretty standard stuff. So it's not like all of the concerns in structure of software goes away. It's really just the orchestration layer is a little bit different, but those are some ways to design for scalability from the get-go. Some closing thoughts. When do we use AI agents? we covered this at the beginning, but hopefully you understand it a little bit more, so this may mean more to you now. We talked about those open-ended problems. There is not a fixed answer for a conversation about where to go in Paris. It depends on the user. It depends on the time of year. And if you were to try to program that in with business logic, it would be terrible, right? So that hopefully those examples made this use case or this kind of criterion a little bit more concrete, open-ended problems. Secondly, multi-step processes. If you have a process like the customer service bot where we talked about, it goes through a solution, gets compliance checked, and then if it's approved, they recommend to the customer. If the customer likes that and wants to go ahead, then it goes to a refund, and then there's a refund agent, multi-step process. The way that those interact, it may change. Your business processes may change. And if they do, maybe there's some new government requirement to perform some sort of check. Well, you can add that check by adding another agent without completely reprogramming the entire business process, right? And so that's really where those multi-step processes, they become flexible. And that also kind of ties into the improvement over time. And then lastly, I just want to say thank you for your time. There's a link, a QR code here, and you can scan that and provide information in a survey. If you want to say that I did a wonderful job, awesome. If you want to say it was terrible, that's cool too. Just let me know your feedback, and we'll take that to heart and try to do something productive with it. But next, we have some ways to help you. So you obviously came here because you're interested and you want to do something, or maybe you're just learning. But regardless, if you're at a beginning of that maturity curve, or if you're further along, we have some way to interact with you and to help you out. And we do really love to help our clients. So first is we have an envisioning session. We can talk about what it is, what are your pain points, what are some of the tooling, what are some of the options we have to solve those, kind of get you up to speed about what the different solutions, brainstorm with you on that. We also have things like automation tooling, et cetera. So I'll stop there. And the last one is we can even bring an event to you. If you want us to come and present something, a topic to your organization, we can definitely discuss that.
Nick, you got a couple questions if you want to look in the chat.
Okay.
You have a couple questions in there.
Gotcha. Thank you. All right. Let me see. Okay, so first question was, by not putting compliance in the customer service agent, is this guaranteeing the customer service agent doesn't have access to the private docs? Does it allow each agent to be more efficient at their jobs by limiting their knowledge? Why not roll them into one agent? Though that's a really good question. It could be that you don't want to have that customer service agent to have access to it, but likely you would want them to have access to the right information. And that user, we'd want to have them authenticate to the tool so that when the AI agent is making its calls, it's using the specific authentication of that user to access the tooling, all right? But why use it? Believe it or not, it's kind of like if you've ever written a paper or if you've done some work, it's kind of hard to find your own mistakes, especially because your focus isn't necessarily on 100% accuracy. It's creating the thing. Like, it's more of the creative process. And that's where these maker checker patterns come in. You have an LLM, like there's a process where you say, hey, create this document for me and include links to relevant articles. The AI agent make up links. Like, the links actually don't even exist. And why did it do that in the first place? And it just does sometimes, right? It gets creative. And so then the maker checker pattern just ensures it's an extra layer that your job, your mission, and the LLMs have a mission, right? The customer service is in charge of making the customer happy. Like, we want them to make the customer happy. We want them to, do these certain things. Now, the compliance agent, you want to ensure that you're supporting the customer service agent, but you also have to make sure your primary mission is to make sure that any solution offered matches these compliance documents. And so by giving it, when we talked about that AI agent, it has three tests. It has the tools, it has the memory, and it has the actions. It has its mission, its identity. By giving that one compliance agent a different identity that's focused on compliance, it actually performs differently. So hopefully that answered that question, but that's a really good question. The next question is, does this solution, and maybe Adrian, if you're still there, if that doesn't answer the question, just put a note in the chat and I'll try to answer it in a better way. Alexander asked the question, does this solution resolve the situation where one agent can understand requests coming in and can involve other agents and communicate back through API? In other words, MCP, oh, thank you, Adrian. MCP complemented by A2A. I'm not sure what, I'm guessing I'm not really sure what these acronyms mean, but the other parts of what you're saying, having the multi-agent collaboration framework, yes. So you have one agent can understand the request, and then it asks, there are different communication patterns. There's group chat patterns. The way that you define who gets called on next, yes, absolutely. That's more related to the specific business process that you're delivering or solving with the solution. And so, Alexander, yeah, you program that in there, how they interact, how they hand off control from one agent to the other. And yes, so one agent can call, you could have an orchestration agent for a process where that agent they don't actually do any of the work. They just know which agent to call when, given the situation. So yeah, that's what you would address there. Alexander, if I did not answer your question thoroughly, maybe define the MCP and A2A. If I got you, great. Then the other question we have is from Emmanuel. Can you add custom tools for agents to use in a multi-agent workflow? Yes, 100%. And so what do those tools look like? They can be code. It could be functions that you program. It doesn't have to be an API, but it could be you describe the tool and how to interface with the tool, and then it knows when to use the tool and how to interface with it based off of the information you gave it. So you kind of define the IO and that. So it could be lots of things. Excuse me. But yes, you can definitely build those custom tooling. Okay, great. So it sounds like that's all the questions. So again, please fill out that survey for us, and we would love to connect with you and just listen to the challenges you're having or the dreams and aspirations you have as a company for AI, and we'd love to help you along and partner with you on that journey. Hopefully this was useful for you, and y'all have a great day, and thank you so much for joining.